Hello, and welcome to Code Clinic. My name is Kevin Skoglund. Code Clinic is a monthly course where a unique problem is introduced to a collection of lynda.com authors. In response, each author will create a solution using their programming language of choice. You can learn several things from Code Clinic: different approaches to solving a problem, the pros and cons of different languages, and some tips and tricks to incorporate into your own coding practices. This month, we'll work on a problem in statistical analysis, and to some extent, handling big data. It's common to use a computer to manipulate and summarize large amounts of information, providing important insights on how to improve or handle a situation. In this problem, we'll use weather data collected by the U.S. Navy from Lake Pend Oreille in northern Idaho. Lake Pend Oreille is the fifth deepest freshwater lake in the United States, so deep in fact that the U.S. Navy uses it to test submarines. As part of that testing, the U.S. Navy compiles an exhaustive list of weather statistics: wind speed, air temperature, barometric pressure, and more. You can browse this data by pointing your web browser at http://lpo.dt.navy.mil. You'll find several weather summaries, a webcam, and the raw data that they collect every 5 minutes, archived as standard text files. For anyone living or working on Lake Pend Oreille, weather statistics are an important part of everyday life. Average wind speed can be very different than median wind speed, especially if you're on a small boat in the middle of the lake. In this challenge, each of our authors will use their favorite language to calculate the mean and median of the wind speed, air temperature, and barometric pressure recorded at the Deep Moor Station for a given range of dates. First, let's briefly review mean and median. These are both statistics. To explain statistics, we need to start with a set of numbers. So how about 14 readings for wind gust at Deep Moor Weather Station on January 1st, 2014. You can see the data at this website. The first column is the day the wind gust was recorded. The second column is the time it was recorded. And the third column is the wind gust in miles per hour. The mean is also known as the average. To calculate the mean of a range of numbers, simply add the values in the set and then divide by the number of values. In this example, we add 14 plus 14, 11 plus 11 plus 11 plus 11 plus 11 plus 3 plus 7 plus 7 plus 7 plus 7 plus 4 plus 8. Then we divide the sum by 14, the count of numbers that were in the set. In this case, the mean is equal to 9. The median is the number halfway between all the values in a sorted range of values. Think of the median as in the median strip of the road. It always marks the center of the road. To calculate the median, first sort the numbers from lowest to highest. If there's an odd number of values, then just take the middle number. But if there's an even number of values, then calculate the average of the two central numbers. In this case, there's an even number of values, so we sort, then we take the average of the middle two values, 8 and 11, and the median is 9.5. In addition, some authors have chosen to implement a web service, allowing other websites to access the new weather statistics created by the author's program. This is typically done by creating a RESTful API, which, when called, returns information in a known format, such as JSON. For a detailed description of JSON and its uses, please refer to JavaScript in JSON by Ray Villalobos. In our case, if I make this HTTP call, I would expect to receive the mean and median for wind speed, air temperature, and barometric pressure for the range of dates starting with March 19th, 2011 and running until midnight of March 20th, 2011. The JSON data would look something like this. So, there's our first challenge. Pull statistics from a data set available online. Perhaps you want to pause and create a solution of your own. How would you solve this problem? In the next videos, I'll show you how I solved the challenge.